Hello friends, next topic is minimization of DFA. Minimization of DFA. Minimization of DFA, deterministic finite automata. What is the minimization? If you had remembered, I told you for one language we can have many DFAs, but minimal DFA is unique. Minimal DFA is unique. So what is the minimization? There is a DFA that is not minimum, so we find out the minimal DFA. We find out the minimal DFA, that is known as minimization of DFA. For this we need we use equivalence theorem. ठीक है, clear? So first we understand what are the equivalent states. Listen carefully. First we understand what are the equivalent states. Suppose A and B, two states. These are two states. If they are equivalent, then we can merge these two states into a single state. If they are not equivalent, then we cannot merge this state. When these two states are equivalent, see, if A on W belongs to final state, that implies that B on W goes to final state. If this condition is satisfied, then we can say A and B are equivalent state, and we can merge either A on W belongs to non-final state, that implies that B on W belongs to non-final state. If these two conditions are satisfied, then we can say A and B are equivalent. A and B are equivalent. We can merge these two states. Otherwise, we cannot merge these two states. Clear? Clear? What is zero equivalence? What is one equivalence? What is two equivalent? Please see. Whenever length of the string is 0, it is zero equivalence. Zero equivalence. Whenever the length of the string is 0, then we can say these states are zero equivalent. Whenever length of the string is 1, it is 1 equivalent, and so on. If length of the string is 2, it is 2 equivalent. Clear? Clear? Now see what is the minimization, how to work this algorithm. We will see with the example. Clear? See, this is the DFA Q0, Q1, Q2, Q3, Q4, transition on A, on B, on A, B, B, A, B, A, B. Check this is DFA or not. This state have two transition, Q1 have two transition, Q2 have two transition, Q3 have two transition, Q4 have two transition. Check whether the given DFA is minimized, minimal or not. If it is not minimal, then find out the minimal DFA. Then find out the minimal DFA. Please, what is the step number first? Step number first. Please listen carefully. Step number first. Step number first. If there are any state which are unreachable from the initial state, delete those state and corresponding transitions. Check. There is any state which are not reachable from the initial state, delete those states. Check there are any state which are not reachable from the initial state. Delete those state and corresponding transitions. Define corresponding transition. What is the first step? Select those state which are not reachable from the initial state. Delete those state and corresponding transitions. Define. Clear? Second step. Find out the zero equivalence set. What is the zero equivalence set? Divide total DFA into two groups. Final state in one group and non-final state in one group. Q0, Q1, Q2, Q3. This is one set and this is another set. These all are non-final state and this one is final state. This is known as zero equivalence. Please, it is very easy. Please listen carefully. Well, okay. Now, what is the third step? Find out the one equivalence set. Okay. How to find the one equivalence set? Please see. Check. Q0 and Q1 are one equivalence or not. Select. Check. What is the transition of Q0 on A? On the previous step 2. What is the transition of A on Q0 in this group? Q1. What is the transition of B on Q0? Same, this set. This is the 0. Q0. Now check. Q1 is 1 equivalent Q0 or not? Q1 is 1 equivalent Q0 or not? Now check. Q1 on A in this group, Q1 on B, same group. It means Q0 and Q1 are 1 equivalent. Now check. Q2 is 1 equivalent to Q0 or Q1. What is the transition? Q2 on A, same in this set. Q2 on B, the transition in this set. It means these three are 1 equivalent. Now check Q3 is 1 equivalent or not. Q3 on A in this group and Q3 on B in this group. It means Q3 is not 1 equivalent to Q0, Q1, Q2. What will happen? Make another set for Q3. This is Q4. Q0, Q1, Q2 are 1 equivalent. Clear? This is final. These are non-final state. We cannot merge final, non-final. We can only merge final or non-final final. Now, next step. Fourth. Check these three are 2 equivalent or not. Check. These three states are equivalent or not. Now check. What is the transition of Q0 on A? On A. This set. On B, this set. Q1 on A, same this set. Q1 on B, Q1 on B. Here. It means Q0 and Q1 are not equivalent. Now check. Q2 is equivalent to Q0 or Q1. Q2 on A, 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 this set. Q2 on B, same this set. It means Q2 is equivalent to Q0. Now, these are the sets which are 2 equivalent. Next, check these two are equivalent or not. Now, further check these two sets are equivalent or not. Q0 and Q2 are equivalent or not. Q0 on A, Q0 on A, Q1. Q0 on A, Q1. Q0 on B, Q2 in this set. Now check for Q2. Q2 on A, same here. Q2 on B in this group. It means we cannot differentiate Q0 and Q2. These two states are equivalent. We can merge Q0 and Q2. These are the states. This is 3 equivalent. Now, when we will stop this process? When K and K plus 1 step are same. K and K plus step are same. See, this and this step are same. Stop this process. These are the number of states in minimal DFA. These are the number of states in minimal DFA. Please check. These are the number of in minimal DFA. Q0 and Q2. Single state. We can merge Q0 and Q2. This is Q1. This is Q3. And this one is Q4. Q4 is the final. Q0 on A, Q1. Q0 on B, Q2. Okay, Q1 on A, Q1, Q2 on B, Q3, Q4, Q3 on A, Q1, Q3 on B, Q4, Q4 on A, Q1, Q4 on B, Q02. This is the minimized DFA. Minimal DFA contain number of states are 4. This DFA contain 5. Clear? Please check this. Check. See, another method for minimization. Another method for minimization. Table method, which already seen in DFA. Construct the transition table for this DFA. A, B, Q0, Q1, Q2, Q3, Q4. This is the final state and this is the initial state. We cannot merge non-final, final, and we cannot merge non-final and final. We can merge only final states or non-final state. Q0 on A, Q1, Q0 on B, Q2, Q1 on A, Q1, Q1 on B, Q3, Q2 on A, Q1, Q2 on B, Q2, Q3 on A, Q1, Q3 on B, Q4, Q4 on A, Q1, Q2. Now, check. There is any common transition? Yes, see. These two transitions are same. These two transitions are same. Also, this is same, Q1 and Q2, but this is the final state and these two are non-final state. Please listen carefully. This one is Q1, this one is Q2, this one Q1, Q2, Q1, Q2. But this is the final state and these two states are non-final. That's why we can merge Q0 and Q2, but we cannot merge with Q4. So Q0 and Q1, Q0 equivalent to Q2, we can write this state as Q02. So this one is Q02, 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 02, 02. See, these two states are same. Remove this state. 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 This state is not present. This state is not present. Then how many number of states are remaining? 1, 2, 3, 4. Minimal DFA contain 4 number of states. Clear? Please check. Okay, good. Do next question. Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7. This is the initial state and Q2 is the final state. Q0 on 0, Q1, Q0 on 1, Q5, Q1 on 0, Q6, Q1 on 1, Q2, Q2 on 1, Q2, Q2 on 0, Q0, Q3 on 0, 0, Q3 on 1, Q6, Q4 on 0, Q7, Q4 on 1, Q5, Q5 on 0, Q2, Q5 on 1, Q6, Q6 on 0, Q0, Q6 on 1, Q4, no, Q7 on 0, Q7 on 1, Q2. Find out the minimal DFA or minimize this DFA. Minimize this DFA. Minimize the DFA. Do fast. Take 2-3 minutes and try to do this. Check there are any unreachable state or not. If there is any unreachable state, delete those state and corresponding transitions defined between them. Check. Q1 reachable from the initial state? Yes. Q2 is reachable from the initial state? Yes. Q3 is unreachable state. Q3 is unreachable state. Q3 is unreachable because there is no path between Q0 and Q3. But Q7 is not unreachable. We can reach Q7 as Q0 to Q1, Q1 to Q2, Q4, Q0 to Q1, Q1 to Q6, Q6 to Q4, and for Q4 to Q7. There is a path exists between Q0 and Q7, but there is no path between Q0 and Q3. It means Q3 is unreachable state. Delete Q3. Delete Q3. Delete Q3 and corresponding transitions define between them. Clear? Now, first we can use equivalence method or transition table method. Use transition table method. Check 0, 1, Q0, Q1, Q2, Q4, Q5, Q6, Q7. Clear? Clear? Q0 on 0, Q1. Q0 on 1, Q5. Is it clear? Now, Q1 on 0, Q6. Q1 on 1, Q2. Q2 is the final state. Q2 on 0, where is 0? Q0. Q2 on 1, Q1. Sorry, Q2. Okay. Q4. Now check because we delete Q3 because Q3 is the unreachable state. Unreachable state. Clear? Now, Q4. Q4 on 0, Q7. Q4 on 1, Q5. Q5. Q5 on 0, Q2. Q5 on 1, Q6. Q6 on 0. This is the 0. Q6. Q6 on 1. This is Q4. Now Q7. Q7 on 0. Q6. Q7 on 1. Q2. Now check. There are any common transitions or not? Please check. Listen carefully. Q15. There is any Q15? No. Q62. Q62. 62. 62. 62. Yes. This one and this one are same. Okay. Now Q45. Q0, Q2. There is any? No. Q75. Q75. Q2, Q6. Q2, Q6. No. 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 Now Q0 equivalent to Q1 is equivalent to Q7. Q1 is equivalent to Q7 because Q1 on 0, 6, Q1 on Q7 on 0, Q6, Q1 on 1, Q2, Q7 on 1, Q2. This is non-final and this one is final. It means Q1 and Q7 are equivalent. We can merge Q1, Q7 as Q17. Q17. Now, this one is Q17. 1 7 1 7 1 7. Remove this state. Remove this state. Okay. Now check. Now check. There are any common transition or not? Now check. This one is Q17, Q5. This is also Q17, Q5. It means we it means we can merge Q0, Q4, Q0, Q4, Q0, Q0 and Q4 are equivalent. We called Q0, Q4. See, this is 175, 175. We can merge Q0, Q4, Q0, Q4. We can write Q04, Q04, 04, 04. Now, remove this state also. Remove this state also. Now, how many number of states we have? 1, 2, 3, 4, 5. Instead of 7 states, we have 5 states. We have 5 states. We merge Q0, Q4 and Q1, Q5. I think we have only 4 states. Please wait. Okay. Initially we have 8 states. Now we have 5 states. We merge Q0, Q4 as Q04, Q1, Q5. Sorry, Q1, Q7 as Q17. After minimization, we have only 5 states. Which one? Q0, Q4, Q17, Q2, Q5, Q6. Okay. This is the minimization of DFA. Clear? Are you getting my point? If you have any doubt, then you can ask me. Now do next question. Do next question. Q0, B, A, Q1, Q2, Q3, Q3 on A, Q3 on B, A, B. Do fast. Minimize this DFA. Minimize this DFA. Minimize. Take 2 or 3 minutes and minimize this DFA. Have you done this question? No. Okay, see. Check, there is any unreachable state? Yes. This is the unreachable state. We cannot reach from the initial state. Delete those state and corresponding transitions. Okay. Now, find out the zero equivalence. Make the set final and non-final. Q1, Q2. Okay, this is the zero equivalence. This is zero equivalent. Now check. This is the single element in the set, so we cannot change this. Now check, these two states are equivalent or not. These two states are equivalent. Q1 and Q2 are equivalent or not. Q1 on A, Q2 means final. Q2 on A, Q2 on A means final. Q1 on B, final is same set. Q2 on B on same set. It means Q1 and Q2 are equivalent. We cannot differentiate these two states. This is one equivalent. Stop this process. Whenever K and K plus one step are same, stop this process. Merge these two states into a single state known as Q1, Q2. In minimal DFA, we can have only two states, Q0, Q1, Q2. This is the minimized DFA. This is the minimized DFA. Check by the transition table. Do yourself by the transition table. Okay, see. A, B, Q0 on A, Q1, Q0 on B, Q0, Q1 on B, Q1 on A, Q2, Q1 on B, Q1, Q2 on A, Q1, Q2 on A, Q1, Q2 on B, Q2. See, these are the two final states. Q1, Q2, we can merge these two states. Q1, Q2, we can merge the C. Q1 on A goes to Q2, which is final state. It is implies that Q2 on A, Q1, this is also final. It means, now check for B, Q1 on B belongs to Q1, that is final, implies that Q2 on B, Q2, that is also final. It means Q1 and Q2 are equivalent. We can merge these two states into a single state. Clear hai? Are you getting my point? Okay.